Okay, so we're doing shape and measurement, obviously. We did our first chapter, which was all Pythagoras, which was triangles, but using that formula. Now we're moving on to other shapes, and we're going to look at, in this chapter, is perimeter and area. So perimeter is just when you're finding the outside length. So you just like if you were putting a border along it, that's what you're finding, and area is when you're obviously finding more of the space. Okay, so we're going to have a lot of different formulas for this, all the different shapes, but you can see I put the formula sheet on the back of your notes so that you can quickly find it when we mix all the questions up. So let's do a few examples. So we've got finding the perimeter of a rectangle. So you should write out your formula, so in case you stuff it up, you can get consequential marks. So the perimeter of a rectangle is always 2 lengths plus 2 times the width. So if you look over here, doesn't matter which one you call length and width as long as they're opposite. So we've got 2 times 12 plus 2 times 5. So we end up with 34, and you've got to read the units, and perimeter is just centimeters, so you're just measuring around the side for that. Really easy. Okay, so when this one, they're asking us to find the area of the shape. So you've got to have a look at the shape, and if you have a look at the back on your formula page, I reckon that this shape looks like a trapezoid. A trapezium, or they called it a trapezoid. Okay, so we are asked to find the area. So the area formula on your formula sheet for a trapezoid is saying area equals a half. Now they're saying B1 plus B2 times the H. So let me show you what that means. What they're calling those B1 and B2, they're calling them like the baselines. So I might call this one up here B1 and this one down here B2. So when you have a trapezium like that, they're going to call that the straight parallel lines, the B1 and the B2. Okay, so when I say parallel lines, I mean these lines that are parallel like that. Okay, then it's asking you for the height as well in the formula, and they've given that there. So you can see what that one is. So once you've written the formula, you then substitute in your values. So V1 was 4.9, B2 was 7.6, and H was 5.8. So when you just got a letter outside the bracket like that, that means times. So you're going to times that all out on your calculator. Now just be careful when you're using a formula. A formula always has to have the units the same. So I probably should have checked to make sure they were all the same, which they are. Okay, you've got to make them all the same before you do it. Okay, so when you times all them out, so that would be, sorry, that would be a times in there too. We end up with 36.25. Now because it's area is measured in squared units. So it means we have the little 2 up there. So it's 36.25 centimetres squared. Okay, with this one, it says find the area of a triangle. Now, I'm not sure if this one was written on your formula sheet, but we just finished. It's not, so you might want to add it in. When we had all 3 sides of a triangle that's not a right angle triangle, what was the name given to that formula? Started with H. It was Heron's formula. Okay, so Heron's formula for a triangle where area equaled, and it was the square root of S minus A, S minus B, S minus C, okay? Where you found S by going a half, all the sides added up. Okay, so we have to go back. Okay, we go back and label the triangle. A, B, C. So we need, that's little a, that's little b, little c. So you first have to find S. So we'll find the value of S. So find S, which is 1/2, and then times all the sides added up. Okay, so when you do that in your calculator, you get... Alright, so 5.75, that's what S equals. So now I can use the area. I know that the area is the square root of the S number, which is 5.75, times, and then you do the S number minus A, which was 3.5, times the S number minus the B, and then finally the S minus the C. Okay, so what you're typing in on the calculator is actually just this part here. So you do the square root symbol and then type all of that underneath and you'll get your answer. So let's go find that out. So I got that to be now they said 2 decimal places, so 5.17 centimeters squared. Okay, a display board in a classroom measures 150 by 90 centimeters. So it's always good to draw a diagram. So just draw it out. And so obviously you've got a display board. The longer side's obviously 150 centimeters. The shorter side, 90 centimeters. So if ribbon costs 55 cents per meter, how much will it cost to add ribbon to border the display? So what you're going to do is you're going to add ribbon. So really, you're finding the perimeter there. So you need to know what the perimeter is. So off we go. We're going to find the perimeter of a rectangle. So the perimeter of a rectangle is 2 lengths plus 2w. So this one will be 2 times 150 plus 2 times 90, which will equal 480 centimeters. But what we have to be careful is the cost is written in meters. So I'm going to change this. So change to meters. So if you want to change to meters, you're going to divide by 100 because there's 100 centimeters in a meter. So then we end up with 4.8 meters. Alright, so then if it costs 55 cents per meter, all you have to do is the cost will equal 4.8 meters times the 55 cents a meter. Okay, so we end up with $2.64 to buy the ribbon. Okay, and then the display board is to be covered with yellow paper. So you're going to colour this thing in yellow paper. So you're pretty much finding the area. What is the area to be covered? Give your answers in meters squared. So because we have to go meters squared, well, it's probably going to be better for us to change our original measurements to meters. So we'll change this. So 1.5 centimeters is 150 centimeters is 1.5 meters, and 90 centimeters is 0.9 meters. All right, so area of a rectangle, if you look it up, is length times width. So we've got 1.5 times 0.9. You do that on your calculator. What do you get? Get 1.35 meters squared. And it says give your answer to 2 decimal places, which we have done that anyway. A gable window at a reception venue. So a gable, what a gable is this bit here. When you have a pointed bit, that's a gable. So a gable window at a reception venue is to have LED lights around its perimeter, but not along the bottom of the window. So it's only going to do this part there. Okay, the window is 2.5 meters wide and the height of the room is 2 meters and the height of the gable is 1 meters as shown. So calculate the LED lights needed to correct to 2 decimal places. So if you break it up, you've obviously got another, you've got another 2 meters here. So we'd have the 2 meters plus the 2 meters. But what we need is this length here. And we don't know what that is. But what I'm going to do is I'm going to create a right angle triangle in there. So if I draw that out like this, so what is the height of that gable part? So what's
1 meter.
Yeah, good. So we got this is the 1 meter. Okay, and we need to know now, what about this length here? What would that be? That's along here. Why is it why it's 1.25? Good, because it's half of that. Okay, so we know that's 1.25. So we can use Pythagoras to find out, because I'll call that little length C. So we know Pythagoras, C squared equals A squared plus B squared. So we're going to call this one A, this one B. And they were all meters, So we're going to write C squared equals 1.25 squared plus 1 squared. Then you're going to pop into the calculator, you're going to use solve, comma, C. And let's find out what... They said to 2 decimal places, so I'll find this one to 2 decimal place, which is 1.60. So I know this is 1.6, this is 1.6. So when we find the total perimeter, so total LED that we need will be the 2 meters plus the 2 meters. So they're those 2 sides over here. And then we've got plus 1.6 meters plus 1.6 meters. So we end up with 7.2 meters needed. The glass in the window needs to be replaced. Find the total area of the window. So with part B, when you've got these, it's what we say composite shapes. So to find the area, you're going to break it up. I'm going to use the rectangle down bottom, which was a 2 meters by a 2.5. And then I'm going to add the gable part, which we know the height was 1. And what's the width of the whole gable? What's the width of that pointy bit at the top? Along here, it's going to be the same, isn't it? 2.5. So that's 1 and 2.5. So what you're going to do, so I'm moving it up. What you're going to do is you're going to write the formulas under that. So the area for a rectangle, you do length times width. And the area of a triangle can be half base times height. And then we'll just sub in the numbers. So we've got 2 times 2.5 plus a half times 2.5 times 1. And, sorry, running out of room. I'm going to go over here. So equals, do that all on your calc. So 6.25. Okay, and that would be meters squared. So what, it said correct to 2 decimal places, but that is 2 decimal places. So 6.25 meters squared, and you're done.